Dimension and dimensional formula. Students, today we are going to discuss about the dimension and dimensional formula. If any physical quantity is represented by m, l, t, means mass, length and time, in such a way q is equal to m raised to the power a, l raised to the power b, t raised to the power c. Then here this formula is called dimensional formula. Above formula is called dimensional formula, and the powers of the basic units are called dimensions. In a book example, A, B and C are called dimensions. Now come to the dimension formula of different physical quantities. Serial number, physical quantity, formula and dimensional formula. First is like area. Area is length into breadth, means L into B, and L is measured by meter. It is the unit of length. Again, breadth is also measured by the unit of length. It will be equal to L2, and in the form of dimensional formula, mass is 0, L is 2, time is 0. The second is volume. Length into breadth into height. All are measured by the unit of length. So L1 into L1 into L1, that is equal to M0 L3 T0. Third is speed or velocity. It is equal to displacement upon time. Displacement is measured by the unit of length. Time is T1 and it will be represented by L1 T minus 1. So dimensional formula will be M0 L1 T minus 1. Fourth is acceleration. Acceleration is equal to velocity upon time. The dimensional formula of velocity is L1 T minus 1 upon time is T1, and it is equal to L1 T minus 2. So it is represented by M0 L1 T minus 2. Fifth is force. force is equal to mass into acceleration, and we know that here m will be 1, acceleration is L1 t minus 2 as given in above relation. Next one is sixth, work done. Work is equal to force into displacement. We know that force is m1 L1 t minus 2. Displacement is, so finally m1 L t minus 2 will be the dimension of the work. Sixth is seventh formula is energy, that is kinetic energy. Kinetic energy K is equal to half mv square. We know that m1 and v square is L1 t minus 1 whole square. It is equal to m1 L2 t minus 2. It is also equal to the work done. Potential energy, that potential gravitational potential energy is U is equal to mgh. Here m is mass 1, g acceleration L1 t minus 2, and h is height. It is measured by the unit of length. So it will be again m1 L2 t minus 2. So dimension of all the energies, kinetic energy, potential energy, will be equal to the work done. The ninth is momentum. Momentum P is equal to mv. We know that m1 v L1 t minus 1 as earlier. So dimensional formula will be equal to m1 L1 t minus 1. Now, 10th is pressure. Pressure is equal to the force upon area. Force is given m1 L1 t minus 2 upon area L2. And finally, it is represented by m1 L minus 1 because 2 becomes minus 2 in upward according to the law of indices. 11th is stress. Stress is equal to the force upon area also, and its dimension is equal to the pressure m1 L minus 1 t minus 2. 12th is strain. There are three types of strain: longitudinal strain, it is change in delta L, change in length upon initial length, change in area upon initial area, change in volume upon initial volume. Means L1 upon L1, L2 upon L2, L3 upon L3. Means its dimension will be M0, L0, T0. It is dimensionless. Now come to the Young's modulus. Young's modulus is also stress upon strain. Stress is m1 L1 t minus 2, m1 L minus 1 t minus 2. and stan is m0 l0 t0. So finally the dimensional formula will be equal to the pressure again, L minus 1 T minus 2, and modulus of rigidity also given the same formula, modulus of rigidity and volumetric modulus. Now next 14th is surface tension. Surface tension T is equal to force per unit length, and its dimension will be m1. Force per unit length means m1 L1 T minus 2 upon L1. So it is equal to m1 L0 T minus 2. 15th is angular displacement. It is equal to theta, and angle is equal to arc upon radius. It is equal to L upon L. It is also dimensionless, m0 L0 T. 16th is angular velocity. Angular velocity omega is theta by t, or we can say d theta by dt is equal to dimensionless m0 L0 t0 upon t1. So it is equal to m0 L0 t minus 1. Angular acceleration, it is alpha is equal to d omega by dt is equal to t minus 1 upon t. It is equal to m0 L0 t minus 2 is t1. Moment of inertia, I is equal to mr square. It is equal to m1 L2. So m1 L2 t0 is the dimension of moment of inertia.